All right, well, let's take a look at some of the loop features or loop-like features that are provided in Lisp next. Again, behind the scenes, these are going to be actually implemented in terms of, say, tail recursion, or actually we'll look at macros next, and these are typically a mix of macros and tail recursive functions. But we'll look at some of the different syntax possibilities that are offered, and in our next session we'll get into the macros that would be used to rewrite these. Alrighty, what have we got? So again, iteration itself is not functionally pure, but you can implement most of this stuff recursively, so you can give the appearance of a loop if you like. The most common one, the easiest one to work with, is dolist. I think we mentioned this one at one point earlier, where you give it a list that you want to go through, and this is kind of like a for each. I want to go through each element of the list. So you give it a list, and you give it a variable name to be used as your kind of index through the list, and this is just going to be whatever the current element is as we work it through, and then you just specify whatever it is I want to do to the current element, and it just goes through, cycles through all of them, and then whatever value it winds up with on the last one is the value that dolist returns. So again, if our list is L and we just want to go through and print all the elements, then I'll say for every element E in L, go through and print whatever E is. So this action, again, can be any valid Lisp statement or function call. Dotimes is another one where it's more focused on performing something a certain number of times. So we're going to provide a counter, that's the variable to kind of keep track of which iteration we're on right now, the number of times we want to repeat some action, and then some return value to specify when this thing finally ends. So if I want X to be my kind of current counter, the current iteration, and I want 4 cycles of this, and each time through I want to print X, and when it's all done, I want to return the square of whatever the last X value is, then this would go through and say, okay, let's print 0, then print 1, then print 2, then print 3, and then return 16. So it will actually go through and perform our cycles and stop on when we hit that value. When we hit the value that terminates the loop, we'll use that in our final computation. So dotimes, again, more focused on specifying a number of times that we want to do things. The one that's most interesting for us is the do loop. So for this one, we can specify a whole bunch of different pieces of information. So we can give a list of local variables, and these you can think of kind of like the initialization of a for statement, where for your for loop you can specify an initial value, how to update it, right, its name. So we're going to do that for each of our local variables. We'll give it a name, we'll give it an initial value, and we'll specify how to update it at the end of each cycle through the loop. So you can have a whole bunch of these local variables simultaneously. Then in the second part of this, so we'll have this list of local variables. Then we'll have a list that's essentially our stopping information. So in this list, it'll give a condition under which to stop processing the loop. So when to drop out of the loop. And then we can specify any actions that we take at the end, right? So after we've stopped processing the loop, these are the things to do after. And then finally, a return value for once all of this is done. And then finally, you give the body of the statements that you want to do. So local variables, how to set them up, how to update them, when to stop, what to do after you stop, and what to return once you've finished doing that, and then the things to do on each pass. So there are a lot of pieces in a do, and you can go through and create fairly complex examples here. So in this case, we've got our do, we've got our list of local variables. So we've got 2 local variables, x, and so for x, it's starting off at 5, and each time through the loop, at the end of each pass through the loop, we double x. And we've got y, that's starting off at 100, and at the end of each pass through the loop, we're adding 1 to it. Right? So you can set up some local variables, how to initialize them, how to update them. And then that next section, the stopping section, stop when x is greater than y. When you do stop, print out, in this case, I don't know why, but I'm printing out x times y, right, just to show something that we want to do once this stops. And then the return value, when do finally completes, is to return the sum of x and y. So again, you've got the when to stop, you can have a whole bunch of statements on what to do once you do stop, and then a final one specifying what to return from the do. And then you can have any number of things after this that are just all the things you do every single pass through. So right now I'm just printing x and y each time through. So the do is probably my preferred, just because it's got the most kind of logical structure to it. The other one you're going to run into a lot is loop. So when we talk about macros, we'll come back and talk about loop. Essentially, there has been a ton of different syntax support offered for the loop construct, where you can provide all sorts of different ways to specify this is how I want my loop to behave. So you can give your loop a name. So loop is the construct. We can give it a name and just, whatever symbol you like. You can specify a bunch of different ways to initialize and update local variables. So I can say things like, for variable x is in this list, so that's going to cycle through all the different elements, kind of like a for each if you like. I can say for count from, and so I'm saying count is going to be my variable, and it's going to start at 5, and it's going to increment by 1. And I can say things like while, and some condition is true, do a whole bunch of things using the current values of x and y. So I've got my my while loop, if you like, to go through, and that shouldn't actually be uppercase there. So the loop construct has a huge range. I couldn't even begin to document all of the different possible things you can do with loop. And as soon as we talk about macros, you'll see why so many different possibilities have been added in here. And it's pretty much just developers say, gee, I'd like to be able to express this in a loop. And so somebody writes a macro to do it. All right. Again, for my money, the do is the clearest, most readable one. Obviously, if you find a loop syntax support that expresses very well what you're trying to do, it can be quite readable. But again, it relies on understanding the different possible permutations of our loops. All right, I will leave that there, and we will pick up with, I believe, macros next time around.